All right, this is Form A and Form B from the warm-up quiz that we gave today. Forms A and B are over the universal law of gravitation. We're going to start with Form A, and then we'll take a look at Form B. Form A says the planet Saturn has a mass of 5.68 times 10 to the 26th kilograms, and its moon Titan has a mass of 1.35 times 10 to the 23rd kilograms. Titan orbits at 1.22 million kilometers from Saturn. Given this information, answer the following questions. And we've got three parts that are all related to Saturn and Titan. A here on the front, and then there's a back with a B and a C. So the first one says that Saturn and Titan are represented by the circles on the diagram below, and the force of gravity experienced by Saturn is represented by the arrow in the diagram. So here's Saturn, here's the force of gravity it's experiencing due to Titan, and here's Titan. It says sketch a force vector for the force of gravity acting on Titan in the diagram above. Be sure to accurately represent the magnitude and direction of this force, then explain your reasoning below by referring to specific physics principles. So when I draw this, obviously gravity is an attractive force. So it pulls things toward one another. I do know that when I go to draw in my force, it does need to be pointing towards Saturn. The other thing that I know is that I need to draw it so that it is of equal length. And since I have grid lines here and I can kind of count 1, 2, 3, 1, 2, 3, it needs to be the same magnitude. Okay, and we're going to explain why down here, but when you draw it in, it needs to look like that. Okay, and in terms of the explanation, because it says to accurately represent it and then explain your reasoning, this is a force pair. So according to Newton's third law, for every action there is an equal and opposite reaction. And so even though these objects have different masses, the force of gravity is a force pair. Saturn pulls on Titan, Titan pulls on Saturn. So that is your reasoning. Force pair, Newton's third law, something like that. But that's the specific physics principle that it wants, is that you state that this is a force pair, and so the forces are equal and opposite to each other. All right, on the back, we have parts B and part C. Part B says calculate the force of gravity acting on Titan due to its gravitational attraction to Saturn. Okay, and so for this one, we're going to need to do a calculation using the universal law of gravitation. So we know that the equation for this, Fg equals big G times m1 times m2, and then all of that over the distance between them squared. Okay, that's the equation. And again, you can put G up here, or you can write it in front of the fraction. It's mathematically the exact same thing, so I do not care. But if we want to go ahead and put in numbers, that's going to be 6.67 times 10 to the negative 11th. That's G. And then we're going to multiply the masses. Now the masses were in the question on the front. They told us that Saturn had a mass of 5.68 times 10 to the 26th kilograms, and they told us that Titan had a mass of 1.35 times 10 to the 23rd kilograms. So again, you can flip the paper over to get those values, but that's what they were. And then all of this needs to be divided by the distance between them squared, but the distance between them needs to be in meters because of the units for this. Okay, and that was the one issue, is that they told us that the distance is 1.22 million kilometers. So I need to take my calculator and convert that. Okay, so 1.22 million kilometers, clear. So 1,220,000. Okay, that should be 1.22 million, 3 zeros, 3 digits, and then the 1. So that's 1.22 million. There are 1,000 meters in a kilometer, so I need to multiply this number by 1,000. And that's the value that we want. And we can leave it like that, or if we want, we can get this into scientific notation. I think you can force the calculator to do it. Yep, right there on the Inspire it's a little bit different, but it's the same idea. That's what it is in scientific notation. 1.22 times 10 to the 9th power. And then that has to be squared. So again, please make sure this is in meters. You have to do that conversion. All right, so from here, we're going to go ahead and we're going to put this whole thing in. All right, so we have 6.67 e negative 11 times 5.68 e 26 times 1.35 e 23, and then all of that divided by 1.22 e 9 squared. Actually, let me do it this way. All right, and we get that. Okay, so let's see, force of gravity acting on it due to, we're going to copy that down. Let me double check real quick that I don't have any issues with my parentheses. You can double check if you want and group the whole denominator. It's the same value. Okay, so we're going to write that down as our force of gravity. So Fg equals 3.44 times 10 to the 21 newtons. Again, make sure when you're copying it, you don't just read the coefficient. Also look for the e at the end. That means that you have to write in the exponent. Okay, the next question says, a distant galaxy has a planet the same size and mass as Saturn, with its own moon that has half the mass of Titan, but orbits the same distance away. How does the force of gravitational attraction acting on that distant moon compare to the force you calculated in part B above? So basically it's telling us, hey, we're going to use this same equation to analyze a new scenario, but that the size and mass of the planet is exactly the same, and it orbits the same distance away. So we're not going to change R, we're not going to change M1, but it does tell us that, that the moon has half the mass. So we are going to be looking at a scenario where we have half as much of the mass of the moon. Everything else is the same. And so again, it's just basically what is the relationship between force and mass, and that's a directly proportional relationship. So if I have half the mass for one of my objects and leave everything else the same, I should have half the force of gravity. And that's all this wants, is how does the force of gravity compare? And it says to be specific and provide a factor. So we don't want to say it's less. Okay, we want to say how much less and provide a factor. So we would say it is half as much Fg. And you can explain that with mass or with sentences. And you could say because it's directly proportional. You could even solve it if you wanted to, because your explanation here could include the math. You could resolve it and have half the value here, but you will get half as much of this. All right, so again, how does the force compare? Half as much, directly proportional relationship. All right, that was Form A. So here is Form B. Form B says it's not about Saturn anymore. It is now about Jupiter. And Form B says the planet Jupiter has a mass of 1.89 times 10 to the 27th kilograms, and its moon Callisto has a mass of 1.08 times 10 to the 23rd kilograms. Callisto orbits at 1.88 million kilometers from Jupiter. Given this, answer the following questions. It's the same setup, except this time in the other one we had to draw the vector in. This one is already drawn. So it's showing us forces, but then it's saying that a student drew this, and it's asking if we agree with it. Okay, and so they didn't have to draw their vector, but in looking at this, we talked about it on the last one. In looking at this, we know that this should be a force pair. We know that the forces here need to be equal and opposite. So do I agree? No, I do not. Okay, do I agree? No. this should be a force pair. Okay, if I were to fix it, 1, 2, 3, 1, 2, 3, it should go right here. Okay, it should not be longer. Yes, the mass is less, but it's still a force pair. Okay, now because it has less mass, it would have greater acceleration, but it's still a force pair. We're not drawing an acceleration vector. So again, you can refer here to Newton's third law once again and say for every action there's an equal and opposite reaction, but these two should be equal and opposite. It is a action-reaction force pair. All right, part B. Same exact problem from part A, or form A rather, except we have different numbers because we're no longer dealing with Saturn and Titan, but rather with Jupiter and Callisto. But regardless, it is still Fg equals G m1 m2 over r squared. So when we substitute in, G is still a constant. It's always 6.67 times 10 to the negative 11th. My masses, though, are different. Jupiter has a mass of 1.89 times 10 to the 27th, and Callisto's mass is 1.08 times 10 to the 23rd. All of that divided by the distance between them squared. And just like in Form A, we have the same issue where it gives us the distance of separation in kilometers. So that 1.88 million kilometers needs to be multiplied by 1,000. And again, you can type that into the calculator, but it's going to end up being this, 1.88 times 10 to the 9th after we multiply it. Okay, and again, that needs to be squared. Okay, so this is now what we're going to enter in. So let me go ahead and do that on the calculator. 6.67 e negative 11 times 1.89 e 27 times 1.08 e 23, and then all of that divided by 1.88 e to the 9th squared. Oops. And this is what we get. Okay, so again, we did the same process, typed everything in, divided it by that denominator. Make sure you square the denominator, and we get Fg is 30,556.85 newtons. And by the way, this is the force acting on Callisto. It's also the force acting on Jupiter. All right, next question. A distant galaxy has a planet and moon identical in size to Jupiter and Callisto. However, the moon's orbit is twice the radius. So again, similar thing. We're doing proportional reasoning here, but it has a different change we're looking at. It's saying, hey, these are the same, but this is going to be twice as much. Okay, how does the force of gravitational attraction compare? So this time we're looking at the relationship between radius and force of gravity, or distance of separation and force of gravity, and that is an inverse square relationship. Okay, so it has twice the radius, but that means that we're not just dividing by twice as much, we're dividing by that squared. So again, if it's inverse square, you're going to flip it, okay, which I already did. Twice the radius means factor of 2, flipped it, 1/2, and then you're going to square it. And when you do that, you're going to get 1/4. Okay, so you're going to have 1/4 the Fg because it's an inverse square relationship. Again, you can show your work or whatever. You can recalculate it by doubling the number you put down here. Just double it before you square it, and you'll end up, if you do that, with 1/4 the answer you had here. All right, so again, that's it for Forms A and B. There will be another video for Forms C and D that you're welcome to watch, regardless of which form you completed. All of it will be a good review.